Hello everyone, welcome to the summary lecture of week 3. Today we will talk about what we have covered so far in week 3 of course climate change and extreme events. And then we will also talk about there is a reading assignment or some sort of a very basic assignment. Basically you have to look at the available data sources and all based on what we have covered so far in this particular week. We have discussed mostly about observing and measuring the extreme event, climate source, data set and all. So, I will briefly summarize all the content we have covered so far in week 3, and then we will discuss about the this week's assignment. So, in the first lecture we have started with why climate data matters. So, we have talked about monitoring let us say global climate trends, long term changes in the temperature, precipitation and other climate variables to look at in a certain region if the climate is changing, what would be the impact on let us say different types of climate variables and their response on different types of environmental spheres. Then why it matters, basically we are able to look at what is the extreme weather system or extreme weather conditions in, so that we can timely provide the warnings and preparedness measures to the affected are likely to be affected communities. And we can also inform the policy and decision maker for some sort of very strategic or curated strategies for those regions for mitigation and adaptation strategies. These climate data also very useful because when you have the historical information, that historical information can be used to get an idea about what would be the future would like, what would be the condition in future, or how the future will behave if let us say greenhouse gases are continues to be rising. If the temperature is continuously rising, what would be the impact on extreme precipitation event, extreme weather phenomena, for example cyclone, for example multiple different types of extreme weather, and then based on these pattern or identification of which how the climate system will behave under different climate change scenarios, we can prepare for disaster preparedness, we can develop more effective risk reduction strategies, better infrastructure planning so that we can manage those catastrophes, or let us say we are also able to provide emergency response protocols or some sort of procedures, so that there will be a minimum loss of the if any catastrophic events occurs in a certain part of the world. Therefore, climate data is very important because it can give us a solid background of analysis and modeling. Using the climate data, when we have historical pattern identification, we would be able to look at what is likely to the condition in the future scenario, which means forecasting of extreme events. And based on all these climate modeling, climate analysis, extreme events forecasting, predictions and all, we can make a certain decision of certain region, policy formulation, so that we can have a better plan for mitigation or adaptation in those regions. So, therefore, climate data is very important, and therefore, we need to have different sources of the climate data set to achieve a particular goal, to minimize or let us say the impact of various different climate extremes like that. So, we have talked about in lecture 1 that there are multiple ways we can collect the climate data. The first way is basically the ground observation based tools. These ground observations are generally called let us say weather station, where we have installed different types of devices at one particular place, where they are measuring, these devices are measuring the temperature continuously, precipitation, humidity, wind speed, direction, or multiple evapotranspiration, for example, like that, evaporation, transpiration, like that. Then so weather stations sometimes also called automatic weather stations. So, there are less maintenance, or automatically they can collect the data, and there is a data logger which can collect the record there, and then there is a transmit server or some sort of framework there, which can basically transmit the data from one place to the another place where we are actually pre-processing or processing the data set. So that is called the automatic weather station setup, which is installed several places around the Indian country, and therefore we can use the data set for multiple different purposes, real time monitoring of weather situation or real time forecasting of any sort of extreme weather conditions like that. Then there is a ocean buoys we have talked about. These devices are floating in the ocean surfaces and can continuously measure the sea temperature, salinity, wave height, ocean currents like that. So these are currently also measuring multiple different properties of ocean. Then we have radio sondes, which are basically used for upper atmospheric data set, which can collect the data of different layers of atmosphere, what is their gaseous content, what is the cloud and gaseous or aerosol interactions. So multiple different aerosol physics chemistry data set can be generated from these types of devices. So these are called observational tools and can provide a very real time or accurate information about different places, terrestrial, atmosphere or ocean areas, so that we can able to get a more high accurate data for long term also measure, can develop long term measurement. But the limitation is with this kind of data set are these data sets are point data set, which are limited to one particular local point or locations. Therefore, it is spatial coverage of these data sets are challenges. So we need more investment to cover a wider areas, so that we have more number of stations, so that we can can cover spatial coverage in those regions. And there is a chances if you have more number of stations like that, it will also create some sort of maintenance challenge as well. So that will increase the cost of maintenance also. So this is a some of sort of limitations of field observation data set. The another type of data set is called satellite data set, which are primarily indirect contact with the object or the property of the earth surface or different spheres or different region, where basically we are collecting the data remotely and storing in their devices or transmitting it to the another servers like that. So these are satellite observational data set, which basically can continuously measure the data for global data coverage and can also monitor let us say atmosphere, ocean or terrestrial system continuously, very broad scale. And if you compare to the field observation data set, these are coverage are much wider than the field observation data set, because these data set or field observations are only limited to one particular point, and this satellite observations are can cover a wider region like that. Some of the example like GOES satellite, ESA Sentinel, NASA's Echo and Terra MODIS dataset like that. And these different satellites can measure temperature, cloud cover, sea level changes, greenhouse gases. Instrument like TROPIMI or Sentinel P 5P can also measure multiple greenhouse gases interaction with the atmosphere like that. Then the another types of the data set, when you are integrating your field observation, satellite data set, modeling data set, that is called reanalysis data set or integrating data source. So combining ground, satellite, remote sensing data set can comprehensively coverage or cross validation with the data set, can provide more accurate data and therefore can cover broader scale. So we have also reduced the limitation of the field observation, we have also reduced the limitation of the remotely sensed data here. We have also reduced the uncertainty and errors in your modeling data set. That is called integration of data set from the various sources that can basically cover a larger region with better accuracy, and therefore that can be used for multiple different climate applications. For example, it can be the data set can be your ERA5, NCEP. So these are the some of the climate reanalysis data set. One can use it and to get a more better insight about regional climate monitoring networks like that. So these are all about data availabilities, data types which are available and that can be used for multiple different purposes in the climate science, climate studies. There are emerging technologies are also coming, which are, let's say, CubeSat satellite launches, which are basically a very smaller scale satellites, can cover a larger region and can be have a swarm of these satellite around the globe, and can cover multiple different points, and accurately measure the data set like that. So that is one advancement is people are working on. There is a AI application in the climate data set, so that we can have a non-linear relationship with the multiple variable, and we can explain it. Then we can also do some sort of high resolution remote sensing instrument, and to get an idea about what is the local meteorological or local hydrological conditions of those regions like that. Then there is a future direction can also be let's say real time data processing or integration with your citizen science data, so that we can integrate multiple source of the data from different people, and can also utilize their information with your already available these data set like that. So these are the emerging technologies which are currently underway, and that can also revolutionize the field of climate data acquisition in the coming futures like that. Then we have in the lecture 2 we talked about primarily the sources of error in the climate data, because when you are collecting the data, it is possible that there will be some sort of errors which will be introduced by multiple different procedures or events like that. So these errors broadly can be classified into two parts. One is called systematic error, another is called unsystematic error. Systematic errors means we know about the pattern, we know about how it introduced in the system. Unsystematic is, let's say, the error is completely random. We do not have any control on that particular error like that. So errors in the climate data can be introduced into multiple types. One is your instrumentation error. It could be because of, let's say, sensor malfunctions or calibration issues like that. Then it could be the environmental factor, let's say interface from local obstructions. Then it could be because of human error. It could be, let's say, incorrect manual entries like that. Then it could be, let's say, it can be also because of the data transmission issues, because of the lack of data packets during transfer. Sometimes if you are transferring data from one device to another device, or let's say there is a sensor which are collecting the data, and then that sensor is sending the data to the ground station, it might possible that data can be lost, and therefore you need to have that information in the system that this much amount of data has been already there is a transmission issues. So that is called identification of the source of the errors in the climate data. So when you have identified that, okay, these are the sources where the error can be generated, there are multiple methods which can be also exist, can be used to correct those error. For example, if you have there are detection technique. So for example, we need to detect what type of error is present in the data. Then you can do outlier analysis, data validation with your historical record or observed record like that, and then you can also visually inspect in your time series. So these are the three methods where you can use some sort of detection techniques or error detections. Once error has been determined or detected, you need to correct those errors. So that can be recalibration. Suppose there is a calibration issue in the device, you can recalibrate the model or data or the device. Then you can also use some sort of statistical smoothing which can basically smoothen the data, and therefore that data can be used for multiple different purposes. Or maybe let's say if there is a loss of the complete data, then you can replace that data with some sort of assumption in that time series data set. So that is called correction methods. So in the nutshell, you can describe the data input, error detection, data correction, and then we are doing some sort of verification. Once this is done, then this data can be used for multiple different purposes like that. So this is how basically we can deal with the error which are present in the model or data, and that can be rectified. Okay, so we have also talked about in the lecture 2 that there are multiple softwares, libraries are available. We can use that libraries or softwares to correct the data set, or to at least pre-process the data for different types of modeling or statistical analysis purpose. So there is a library called pandas, numpy, scipy, we have already discussed. There is a dplyr, tidyr, these are the libraries in R which are also available. Then there is a specialized tools which is called climate data operators, NCL, like that, this is also available. So these types of libraries and tools can efficiently handle the large data set. Suppose you have multiple points of data, so you can manually you can look at one data point, but when you have large data set, you need to have some sort of automatic system, so that they can that system can automatically detect the error. So therefore, for the large data set we use that system, and that basically improve the errors in the data. Or there are pre-built functions or gap filling algorithm which are also available in the model in these different types of libraries. So you don't need to write those libraries again and again to basically correct the data set. So these are the some of the libraries, you may look into it, and you can also use for your climate analysis purpose, like that. Then the lecture 3 we have started with discussion of different types of climate models. Climate models we talked about, for example, broadly 4 different models. Earth system models, for example, we talked about the advanced model which is incorporating the biogeochemical cycles. Then we talked about the regional climate model, which is high resolution model for a specific region. Then there is a model called general circulation model, GCM models, which are complex models for simulating atmosphere and oceanic processes. Then we have also talked about energy balance model, which are basically simplified models to focusing on Earth's energy budget. So these are the different types of models which exist, and depending upon, let's say, application of the different purposes, we select the model. Let's suppose we are interested in applying the climate analysis for entire globe for a different time step, or let's say future condition or different scenarios. Then we will run the general circulation model, and that general circulation model will give you information about how the temperature extremes are likely to be changed in future steps under, let's say, a high emission scenario, or under, let's say, a medium emission scenario, or under, let's say, low emission scenarios, or maybe so like this. Or we can also do some sort of more intense analysis with GCM models, like that. If the temperature is rising, what would be the impact on floods, what would be the impacts on different other processes, like that. Let's suppose how the heat waves are likely to be changed if the temperature or maximum temperature is likely to be increased in the future step. So there the global coverage models provides a very valuable tool, very valuable information, and can cover the whole globe, and therefore can covering the global phenomena and large scale phenomena and smaller scale phenomena as well. And then they are interlinking with each other, so that we can have better insight about, suppose if the winter precipitation of Indian region are changing, is there any correlation with the winter western disturbances which is originating from Mediterranean Sea, or is there any correlation with, let's say, ENSO event in the monsoon weakening or monsoon heavy monsoon in certain years, like that. So therefore these are the models which are very useful to get a more detailed idea about the global phenomena in a certain. Let's suppose if you are interested in more advanced climate modeling research in a certain region, let's say only focusing on Indian subcontinent or other regions, like that. So in this part, if you are looking only particular one region, then it is possible that we would be able to model more local scale phenomena compared to GCM, and the results we will produce will be more finer compared to your GCM model. Finer here means we are covering a very finer detail of the topography, or different types of Earth's properties or atmospheric characteristics, and that can produce you a very good result about finer resolutions, different types of climate models or climate variables with their processes like that. So, depending upon different types of application need, we use the data from multiple different sources. In the lecture 3, we have also talked about there is not only one GCMs are established, there are multiple GCMs are established across the world. Some are developed in US, some are developed in Europe. In the Europe, there are multiple countries: Italy, France, Netherlands, or let us say Scandinavian countries, Norway and all, or let us say there are country like Japan, China or India also have their own some sort of climate model that is collaborating with your multiple different global climate models and can providing their results. And once we are trying to identify is there any change in the property, the best practice is we look at the ensemble mean of the model. It is possible that one model is better in vegetation, one model is better in let us say sea ocean interaction or ocean or atmosphere interaction like that. So, to include everything in one platter or one model, it is not possible to include everything in, it will be very complex. So, therefore, what scientists generally use, they take an ensemble mean approach. They take the mean value and then they basically mean value can give you idea about what is the changes in the different climate variables properties. The another thing which we have already discussed in lecture 3 is about validation and calibration, which is very important step in climate modeling, because validation will give you a more confidence about whether the modeling results you are using for multiple different purposes are accurate or not. Calibration is basically when you are using some sort of observed data set with your climate data and you are trying to set up or converge your parameters in your climate model equations. So, that is called calibration. Once the climate model equation has been converged, that equation can be used again, or that modeling framework can be used again for further data set, and that data set will be checked with your rest of your observed data. That is basically called validation of the data set. So, this is basically it is very important step, and it basically give you a more confidence about your modeling setup, whether the perfect, let us say comparing you multiple model. So, which model we should select or which top 5 model we should select, on what basis you will select the model. So, you will select the model based on their validation, their accuracies, whether temperature is correctly predicted by one model in the historical time period or not, or temperature or rainfall let us say is correctly predicted by one model or not. There is another approaches. If suppose the climate models gives you not very accurate temperature or rainfall pattern. So, there are bias corrections also, which basically use the historical data set of your modeling data and historical data set of your observed data set. If you compare all these data together, you can basically reduce the biases. Biases means error which are present in the modeling data historical period, and using the learning of historical data comparison, you can also correct the data in the future steps also. So, that is also called some side of calibration or removing the biases in the model, which is very important. How these what is the limitation of the climate model? Basically, if we do not have a very complete information about any particular process, that can lead to some sort of uncertainty. Parameterization is also another issue. When we do not know exact value of different parameters, that can lead to us a different uncertainty problem. Simplification, if you are overlooking small scale processes, that can also provide some sort of problem with your climate data. And if you are ignoring the topography, if you are not assuming the topography in the model or like that, or different parameters, that can also lead to a problem with your uncertainty or limitation in the climate model. There is also computational intensity. Let us say if you are using high resolution model, then we need to have a very balance between what is the optimum resolution we are taking and what is the computational efficiency we have at the same time. This has to be a cross check manner and balance condition, so that we can perfectly model for a particular desired output like that. So, this is we have so far discussed in lecture 1, lecture 2 and lecture 3 in the week 3 in this particular course. Based on this lecture, now we have already discussed multiple types of data set, their errors, different types of climate models like that. You can look at you can explore the climate data set from different reanalysis product, and also you can look at different types of climate models. You can read about them, you can make a summary of how many types of reanalysis products are there available, where you can use the data for, let us say, historical time period, and then we can also use data from different climate models for different types of analysis purpose. For example, rainfall data, temperature data, or multiple different climate variables like that. So, you look at it, you read the this different data set and reanalysis product. We will discuss about it in the next lecture. About we will introduce some of the reanalysis product through their website and the climate models, so that you can understand that how you can use the data and for your study purposes like that. So, this is all about in this lecture. Thank you so much for your attention.